Hi, good morning, my dear students. I'm Daphne Nicole. Welcome to my STPM Chemistry discussions. Let me ask you a question. Why do you use litmus paper in the lab? So, what is the disadvantage of litmus paper? Litmus paper doesn't show a numerical pH value. Instead, it only indicates whether a sample is an acid or a base. I will discuss how to calculate the pH value of a solution. In STPM syllabus, you need to know how to calculate the pH value of a strong acid and a weak acid. However, in this video, I only focus on how to calculate the pH value of a strong acid or strong base. Now, let's go to the first part, definitions of acids and bases. pH is an important quantity that reflects the chemical conditions of a solution. The pH can control the behavior of a chemical. Therefore, we need to know how to use the pH formula to calculate the pH of the solutions. Before we discuss the pH formula, let's see the subtopic that you need to learn in STPM syllabus. In the part of acid-base concept, we will study about the definitions and learn how to calculate the pH solutions of a strong acid and weak acid. Now, let's look at the definitions of acid and bases. The strength of the acid or bases can be compared in terms of dissociation constant and degree of dissociation. However, the acidity or alkalinity of a solution is expressed by the pH value. To calculate the pH of the solutions, we need to use this formula. This is the pH formula and the definitions for pH and pOH. Pure water is a very poor conductor of electricity. This shows that the degree of dissociation of pure water is very small. Next, this is the relationship between the pH, pOH, and Kw. By using the following formula, we can calculate the pH value of strong acid or strong base. The amount of hydrogen ion concentrations in the solutions determines its pH value. For strong acid, for example HCl, the concentrations of hydrogen ion and the concentrations of the HCl are numerically the same. Therefore, we can calculate the pH value easily if we know the concentrations of the acid. Let's look at example questions 1. To determine the pH value of a solution, we need to determine the concentrations of the hydrogen ion first. For strong acid, it is completely dissociated in water. That means 100% of the strong acid molecule breaks down into its separated ions. Therefore, the concentrations of a strong acid is equal to the concentrations of the hydrogen ions. This is the reason why we can directly substitute the concentrations of the strong acid into the pH formula to determine the pH value of the strong acid. Let's come back to the questions example 1a. Other than hydrochloric acid, there are some other strong acid and strong bases here. These are the steps to calculate the pH value of a strong acid. So this is the information from the questions. Next, we check on the mole ratio of the concentrations of the strong acid and the concentrations of the hydrogen ion. Lastly, the pH of the hydrochloric acid is equal to 1. The strong acid in example B is sulfuric acid, which is diprotic acid. Then check the mole ratio of concentrations of the strong acid and the concentrations of the hydrogens. From the balance equations, the mole ratio of concentrations of strong acid to concentrations of hydrogens ion is equal to 1 to 2. Therefore, the concentrations of hydrogens ion here is equal to 2 times 0.03. Lastly, substitute the concentrations of the hydrogens ion into the pH formula. Next, the solutions in example 1C and 1D are strong bases. Therefore, we can use the following formula to determine the pH of the solutions. After writing the balance equations, let's check the mole ratio of the concentrations of strong base to concentrations of hydroxide ions. After that, we use this formula to determine the pOH of the questions. Lastly, by using this formula, we can determine the pH value of the strong base. Now, let's look at another questions.